All right, composition of functions. So another method besides adding, subtracting, multiplying, and dividing fractions is called composition. You are composing something. You are putting more than one thing together. So if I'm given f of x and g of x, then I have a composite function, f of g of x. That's how we write that, or that's how we say that, rather. And it's written like this. There's two different ways. F, and then that's a little tiny open circle. It's not an O, and it's not a dot. It's like a little tiny open circle. Reads f of g of x, and that's the same thing as f of g of x. I prefer the second way. I think it's much more obvious which one goes inside of the other that way. And when we do this, then we have to make sure that we don't make up math. That's the most important part of all of this, okay? All right, so if I have f and g, and I want to find f of g of x. So let's go ahead and see how this is going to work. So f of g of x, that is the same thing as f of g of x. That means g of x gets substituted into f of x. Because if I said I want to find f of 5, right? F of 5 would mean I put 5 everywhere I see an x in f of x, right? I don't want f of 5, I want f of g of x. So I'm going to take the whole g of x and substitute it in everywhere I see an x in f of x. So that is going to equal x squared minus 4 plus 7. Okay, so instead of x, I put this whole thing, which is x squared minus 4. If you substitute something with more than one term, you put it in parentheses. In this particular case, those parentheses don't really matter, right? All they're doing is grouping stuff. So then when I simplify, because I'm not multiplying this, so when I simplify this, I get that f of g of x is equal to x squared plus 3, because all I have to do is that negative 4 and positive 7. Okay, make sense? What questions you got? Why not x squared? It is x squared. You can't see it because I'm a stupid box. Sorry. No. Oh, because we're not multiplying. This is an addition thing. There's parentheses there, but it's addition. Okay. Good question. Anything else? All right, so let's do then g of f of x, which is g of f of x, like so. So now I'm going to take f of x, this whole thing, and put it in right here everywhere I see an x. So this is equal to, now I'm putting in more than one term, so I have to use parentheses, x plus 7 quantity squared minus 4. So instead of x squared, it's x plus 7 squared. When I go to simplify this, x plus 7 squared is not x squared plus 49. It is not. That is something you go to math jail for, right? X plus 7 squared is x plus 7 times x plus 7. Then you can FOIL that or do the box or whatever works for you. There is a shortcut for this, so I'll just let you know what it is while we do it. If you're going to square a binomial, you square the first term, that's x squared. Then you multiply the two terms together, that's 7x, and you double it. You get plus 14x. And then you square the last term, and we get plus 49. And then minus 4 in the end, because that's had a minus 4 there. Make sense? If you need to FOIL it, or box method, or whatever you do to multiply them, that's fine too. But there are other ways to do it. So then I need to just combine my like terms. So I'm going to get g of f of x. That's equal to x squared plus 14x plus 45. And that is my answer. What questions do you have? Good? All right. Let me get my drink real quick. Let's look at number 2. The first thing I want to do on number 2 is f of g of x. So this equals f of g of x. So I'm going to take g of x, substitute it into f of x. So this equals 3 minus x over x plus 1. So I have 3, which is not a fraction, minus something that is a fraction. And so I want to make them both into fractions, which is super easy. I just put the 3 over 1. Okay. Now I am subtracting fractions. Besides 4th grade math skills, what else do you need when you subtract fractions? Common denominator. Very good. What would your common denominator be here? Not 1, because 1 could just go away. But if this has a denominator of x plus 1, then I need this one too as well, right? Do I just get to put it over x plus 1 and be done with it? No, I have to multiply. So I'd have to multiply this by x plus 1 over x plus 1. Right? That has a value of 1 there. Make sense? That's how you get a common denominator. All right, so then that's going to equal, I'm going to have 3 times x plus 1 over x plus 1 minus x over x plus 1. See how that works? Okay, so now that they both have the same denominators, now I can actually subtract them. So while I do that, I'm also going to distribute this 3. So this is going to give me, in the denominator, x plus 1. Then in the numerator, I have 3x plus 3 minus x. You agree with all that, where it came from? So that means in the numerator, then I get 2x plus 3 over x plus 1. And that equals f of g of x. Could I cancel out the x's here? 100% no. If you have addition or subtraction, that's a big fat no. What's your question? No. You think about them as things. Like if I was going to add 3/4 plus 7/4, right? So I have 3/4 plus 7/4. So I have 3 teddy bears plus 7 teddy bears. So then I'd have 10 teddy bears. Like think of the denominators as things. And the numerator is how many you have of them. So when they're the same, then you just keep the same denominator and take care of the numerator. Okay? What else you got? Do we all understand why we cannot cancel these x's out? Because that would be undoing addition with division, and those aren't opposites there. So I can't, that's it. This is my answer. Okay? What questions do you have? All right, so now let's do g of f of x. See if you can go ahead and get that substituted in. G of f of x. You put f of x everywhere you see an x inside of g of x. Is that what you got when you substituted it in? Right? Because those parentheses represent where that x was. So in the numerator, I don't really need the parentheses, just 3 minus x. In the denominator, I don't need them either. And then that 3 plus 1, I'll get 4 minus x. Can I cancel the x's out? No. That is not going to equal 3/4 in the end. It doesn't work that way. This is g of f of x. What questions do you have? We good? All right, we're going to skip example 3, and we're going to go to example 4. All right, f of g of x. Go ahead and see if you can get that substituted in. F of g of x. Think about which one's on the inside there. Is that what you get when you substitute it in? All I did was substitute it in at this point, yes? Okay, then I have to decide if I can do anything else. I cannot do anything else. I know that the square root of x squared is x, but I have this addition here, and that totally messes things up, and I can't do anything else. This is f of g of x, and I am done. Okay. What questions do you have? All right, so substitute it going the other way. This time I want g of f of x. Get the square root of x plus 5 squared. Do you agree with that? Can I simplify that one more? Yes, if that whole square root is being squared, those are inverses of each other, and that just equals x plus 5, and that is g of f of x. What questions do you have? Okay, we good? All right, flip it over. You do substitute in for example 5. Is that what you get when you substitute it in? Cube root of x plus 4 cubed minus 1? Does a cube undo a cube root? And it's this entire cube root that's being cubed. Those are inverses of each other, so that gives me then just x plus 4 and then minus 1. So that means I get x plus 3, and that equals f of g of x. What questions do you have? All right, you try and do B. When I substitute it in, that's what I get, right? I put in more than one term, so I put those parentheses. Those parentheses do not imply multiplication. They can completely go away and the same work happens. So then this would equal the cube root of x cubed plus 3. I cannot go any farther than that. Okay, so I want to make sure that you understand this. If the cube root of x cubed plus 3 does not equal the cube root of x cubed plus the cube root of 3. Like, you cannot split them up like that because you can't add what's underneath there, right? If it wasn't addition, if it was multiplication, which it's not, but if it was, and I had the cube root of 3 times x cubed, I could simplify that because these are being multiplied, and I could say that this is the cube root of 3 times the cube root of x cubed. That's totally fine because it's multiplication. And then the cube root of x cubed is just x, so I'd have x times the cube root of 3. So that's when I would get to simplify it. I can't here because of addition. The addition and subtraction messes up your square root stuff that sometimes you want to simplify, and your fraction stuff that sometimes you're very tempted to cancel out and you can't. So that means I can't do anything else. This is it. G of f of x. Bam, you're done. Any questions about those? Why we can do something and not something else? Because it'll make sure you get it. All right, so that's when we're putting in the whole equations, or expressions rather, and then there are times where we evaluate it. If you were told to evaluate it, it has the word value in it, so you're going to find a value. You're not going to have an equation in the end, you're going to have a number. So if I want f of g of 3, and I'll say again, I really think it helps to rewrite it like this, f of g of 3. So I am not substituting 3 into f. I'm substituting whatever the value of g of 3 is. So I want to find that first. So work from the inside out. So I'm going to find g of 3. That means I take 3 and substitute it in here. So that's 3 plus 1, which is 4. Okay. So f of g of 3 is the same as f of 4. And that is the absolute value of negative 2 times 4. It's the absolute value of negative 8. So f of g of 3 equals 8. What questions do you have? All right, then you do B. We want g of f of negative 5. Any questions at all? We get it? Not that big of a deal? Review? Yes? All right, so we got some more square root stuff. Got to make sure you're not making up math with square roots here. So we're going to do f of g of 9. So we will find g of 9 first. So that's going to be the square root of 9 minus 4, which is the square root of 5. And I can't do anything with that, right? It is the square root of 5. So then I find f of the square root of 5. That's going to be the square root of 5 squared plus 5 times the square root of 5. What is the square root of 5 squared? 5. The square root of anything squared is itself underneath. I have monkeys over there. The square root of a monkey squared is a monkey. Because like it doesn't matter what's underneath. All the square and the square root are inverses and they're taking care of each other. So this just gives me 5. Plus, and then I have 5 square roots of 5. Is that going to become 10 square root of 5? The answer is no. You treat square roots like variables. That's like 5 plus 5x. That is all I can do. That is f of g of 9. Okay. What questions do you have? Are we good? Don't be afraid to ask anything. I know it's weirder when there's less people in here, but ask. All right, then you do B. All right, so did we get to where we have the square root of 80? Okay, do we know how to simplify square roots? Okay, just in case somebody needs a refresher, here's what, oh, okay, well, I'm going to show you the way I would teach it. Now, if the only way you know how to find perfect, or if the only way you know how to simplify square roots is by looking for the largest perfect square that divides into there, which is how some teachers teach it, that is not the best way for everybody to do every single problem. The tree method, way better. Like if you know, that's great, go for it. But if you have to take any time, just start doing your tree. Now, I do know that 80 is divisible by 4, and that's a perfect square, so I'll start with 4. So I got 4 and 20. And each branch, I'm going to stop either when I get a perfect square or a prime number. So that's a perfect square, I'm going to stop there. And then 20, I can make 4 times 5. So I've got 2 perfect squares and a prime number. Then I look for pairs. So the fact that it's a perfect square isn't really even helping me here. These 2 4s come out as just a plain old 4. This guy's by himself, and he stays underneath. So that means that the square root of 80 is the same as 4 square root of 5. Right? That means that g of f of 7 equals 4 square root of 5. Any questions at all? Awesome. All right, so now we're going to decompose a function where there's more than one right answer to this. So we have taken 2 functions and we've put them together. So now we're going to take one and we're going to take it apart. So what this says is that we're going to find 2 functions, f and g, such that f of g of x equals h of x. Okay, so what it says over there is f of g of x equals this h of x, which they gave me. And this is the same thing as f of g of x. So that equals h of x. And I want to look at it this way because you can clearly see that g of x is the one on the inside, f of x is the one on the outside, right? And again, there's more than one right answer, and we're going to look at more than one right answer on all these. If I ever ask you to do this, which you will on a quiz and a test, you only have to give me one set. We're going to look at more than one set for each one of them because I want you to see there's different ways to look at it. But so here's h of x. I need to find an f of x and a g of x that I could use that when I do f of g of x, I get that. It's easiest to find g of x first because it's the thing on the inside. And you can, again, you can do this a couple of different ways. Let's say that I said g of x is 1 minus 2x. If that's g of x, what would f of x have to be? Good. X to the power 3, x cubed. Okay, because the inside is 1 minus 2x, and if I take this and I substitute it into here, I would get that. Would you agree with that? Do you see how that works? Going the opposite way, we're taking it apart. Another option, say I have f of x that I'm looking for, and g of x. Let's say I said g of x is 2x. Then what do you think f of x would be? Parentheses, then what? 1 minus, I can't even write. 1 minus x cubed. See how I would take this and substitute it in for x, and then I would get that out? Okay. All right, any questions at all? All right, so on number 9, see if you can find, we'll talk about more than one, but you only have to find one on your own. See if you can come up with an f of x and a g of x. If you can come up with more than one, that's great, but you only have to come up with one right now. All right, who wants to give me one? Anybody brave enough? Oh, come on. There's not that many of you in here. Somebody talk to me. Leo, what you got? Okay. Very good. You see how that works? So if that isn't what you wrote down first, write it down because it's correct. Very good. Thank you. Does anybody have anything different? You have something different? Nope. You have the same thing. What if I said g of x is x squared? Okay. And then what would f of x be? Cube root. Okay. Very good. X plus 1. Okay. That makes sense? That works. All right. So try number 10. Try and come up with more than one if you can, but at least come up with one. Daniel, can you give me one? Is that f of x or g of x? Okay. So 4 over x plus 7. Okay. You're going to put the whole thing down here? You mean up here? Okay. Yeah, then x minus 1. Okay, good. That works. Very good. You all agree with that? That totally works. Somebody have something different? What you got? Okay. Perfect. Okay. See, those are totally different, but they both work. Without more knowledge, we don't know where it really started. It could have been something even way different where things canceled out, but we don't need to get crazy. Okay. All right, so try 11. There's lots of different ones on 11. Adrian, can you give me a set? Okay. Perfect. That works. So if you don't have that one written down, write it down because it does work. Very good. Thank you. Jose, do you have anything different? No? Anybody have anything different? What if I said g of x was negative 1/2 absolute value of x plus 5? What would f of x have to be? Yeah, not just a 3, but I'd have to have x plus 3, right? Because I have to have some place to substitute it in. Make sense? And then there's actually one more I want to talk about. We'll have one more down here. What if I said, what if I said that g of x is the absolute value of x plus 5? Because it's very similar to this one, right? But then instead of this, I would have negative 1/2 x plus 3. Okay. And you can have other options by changing signs and stuff like that, but those are just some different ways to look at it, okay? One's not better than the other because we don't have any more information than that, okay? What questions do you have? Anything? You can do compositions? Yes? Awesome.